Good afternoon, everybody. First, I would like to thank the organizer for the invitation and the opportunity to present our project named VIRTIGATION, and which aims at dealing with important viral disease in major crops for the Mediterranean area, which are tomatoes and cucurbits. If there's one good thing about COVID-19 that happened a few years back, is the fact that people have realized that viruses can be a global issue, and what applies to human beings also apply to crops. And this is why we have to take care about the viral diseases. There are two very important diseases that have emerged over the last 5 to 10 years that have occurred first in the Middle East or in India, that have very quickly become important issues globally. So the project aims actually at defining new solutions for mitigation of those important diseases. We have a multi-pronged, holistic approach to address this issue. Of course, we work with stakeholders, which are very important. I should also mention that those two diseases are also an opportunity to bring together Northern Europe with Southern Europe, and of course, partners in the Mediterranean area, because those issues of viruses are very quickly becoming something that expands from north to south or from south to north. So this is something that is also very important and brings people together to work on those issues. As I was saying before, we are trying to develop different solutions, and each component somehow brings some kind of a new product potential or potential for collaboration with people here in this area of the continent. So we develop diagnostic tools to better characterize the virus, to be able to detect early emergence of important virus isolates. We study the interaction between the virus and its vector. I should also mention that this is transmitted by whitefly, those viruses, so they are a very important element to consider in the equation. And of course, we want to develop sustainable solutions to mitigate those problems. And we also have, of course, a training component as we are developing some fact sheets to explain to people how to implement some easy solution to reduce the impact of the diseases. It's a very big consortium of 25 partners, amongst which we have, of course, leading universities, but also extension services, which are very important, and also a big private sector partner like Corteva or Syngenta. This allows us also to benchmark our solutions, or at least to look what is actually having a good potential for product development. It brings different countries in this area. I will skip this part now. And as I said before, we have different implementations. I selected here 3 to illustrate, but I should also mention others that are also very important. The short format doesn't allow me to go too much in details. But we have, for example, developed a pipeline that allows us to test very quickly different biopesticides. So we are trying to replace the synthetic pesticide by some biopesticide, and we have identified using this pipeline a very in silico pipeline. We are able to identify some molecules, or at least some extract that have very strong activity against the whitefly, the vector of the virus. I will skip this. I'm sorry, it's a bit slow, but what we've shown with those results in multi-locations, so we are running those assays in Germany, in Spain, in Italy, in Israel. So we are testing those solutions in multi-location, and this also allows us to demonstrate that those biopesticides are actually highly effective. In some cases, more effective actually than the synthetic components or the synthetic-based biopesticide to which we benchmark our solutions, but also effective in different conditions, in greenhouse in Germany, in plastic greenhouse in Spain, or in open field in Italy, which are also, of course, very important elements for implementation of solutions. And very importantly, we are also, of course, testing those biopesticides to validate that they are not detrimental to beneficial insects. This is also another very important condition for us to achieve a product that can have some potential on the market. We also develop sanitation protocols that are also very important. Some of those viruses, they remain very long, they have a very long survival time on surfaces where they have contact, so it means that you can quickly contaminate and remain contaminated for a very long time. So there is also a need to develop special protocols. We develop some chemical treatment, but also solar radiation approach to reduce the contamination of those diseases. And then, of course, to integrate also in relation to the context we have of this meeting today, we also look at the importance of climate change on those diseases. All results also suggest or indicate that some of those vectors, they might have actually, under climatic changing conditions, they might also acquire much faster the disease, the viruses, but also have a better efficacy to transmit the disease. So we anticipate with our models that there will be more issues with a virus infection in the future. I don't want to annoy you with all the details. Of course, I prepared the presentation. We can discuss this for some of you that are very interested in this research. But what we see here is we see that under future climate conditions, we have stronger acquisition of the virus, and so higher risk to have this problem in the production zones for cucurbits and for tomatoes. So the areas open to collaboration, I should also mention that we are also developing some vaccines, for example, to also mitigate this issue. So really have different approach, reducing transmission of the virus, treating the plants to make sure that they don't develop symptoms, developing procedure to decontaminate the environment with the virus. So we really have different product, or let's say different options on which we could collaborate. We also develop, of course, diagnostic tools to study the virus and make sure that we can have early detection of potentially problematic isolates of the virus. We also develop, of course, sanitation measures, as I mentioned before. So all those 5 areas are for us very important. I should, last but not least, also mention breeding. This is a long-term effort, but in breeding, of course, we are also developing naturally resistant plant material, tomato and cucurbits, that should also be made available to farmers in the future. So let me close this presentation. I thank you for listening, and I'm, of course, very happy to discuss with you if you have questions or if you see potential for collaboration in the near future.